All right, thank you very much, Keith, and thanks for those of you who have stuck around for this last session of the day. We certainly appreciate it. So what I'm excited about today, besides the fact that you all have stuck around even though it's 21 degrees outside, is being able to introduce this session and the theme leads who are going to actually tell you about some of the research that has been going on for the past 5 years within TRIANet, and that is built on work that we've been doing over the last nearly 12 years. So you won't have to listen to me talk for the next while. I'm just going to introduce the network to those few of you who maybe haven't heard this story already about what TRIA is and how we got to where we are today. But you do get to hear encapsulation of this work from 4 very interesting speakers. And this is a prelude to our Thursday and Friday sessions, which I hope that you've made time in your schedules to attend. So as I mentioned, we've been at this for more than a decade now. The initiative was a grassroots initiative that began in 2006. We worked feverishly over 2007 to acquire funding, and the project, TRIA-1 project, initially launched January 1st, 2008. Fast forward to today, we've gone from a regional group of researchers to a national network. And we are really delighted to have some pretty amazing partners involved in this research. And I want to, at this point, really extend a heartfelt thanks to all of our partners who are listed here for their logistic support, for their moral support, for believing in the type of research that we do, and for showing up each and every year to these meetings. TRIANet is obviously more than the scientific team that is listed here. Most of these researchers have been involved since the first phase of TRIA-1, but it's really, as we heard this morning, the students, the postdocs, students extending right from undergraduate students and WISA students, high school students, all the way through to our senior PhD students who have done all of this work. And I'd like to give all those students a great big hand right now. They're the reason why we're here. They're the reason why we fill out annual reports. They're the reasons why we go onto those online forums to make sure they get paid. They're the ones that produce the exquisite research that you're going to hear about not only this afternoon, but later on in the week. So the whole raison d'etre of TRIANet was really to get at this question about mountain pine beetle range expansion into novel habitats, and this burning question about whether population dynamics of mountain pine beetle would differ as this beastie moved into novel habitats. And we've already heard a fair bit today that says, yes, these population dynamics, or at least the factors we think would affect these population dynamics, do differ. And so over these past years, we've been delving into the questions of why. And I always joke at this point that this arrow is actually pointed directly at Keith's cabin. So he's our long-term case study. Will that beetle ever make it to Keith's cabin? And we hope that the answer is no. So we had 3 goals. We wanted to get solid science to address knowledge gaps that existed around this idea about mountain pine beetle spread into novel habitats. We wanted to develop new tools for risk assessment, and we wanted to provide outcomes in real time to our partners because we wanted to guide scientifically based decisions. And so our partners, as we planned TRIANet especially, had a great say in how we structured the research to get at the questions that were important to their various jurisdictions. So one of the benefits that we have in a network is that we can do comprehensive, integrated research. And so within our TRIANet team, we have experts in insects, we have experts in trees, and we have experts in fungi, and we have experts in interaction partners. And so that has enabled us to take this more holistic approach, looking at different aspects of these interactions and the system as a whole. And so we've had 3 cornerstones to the biological analyses that have been done. We've had these molecular analyses of what's going on inside the organism. We've had ecosystem dynamic studies, so how is the organism behaving in its environment? And then population genomics, this is getting at how the genetic variation that controls what's going on inside the organism, how is that influenced over the landscape? So all of these areas ultimately became connected through collaboration. What we were most proud of, I think, is the connection to the mathematical modelers. We've had economic modelers involved in past phases of TRIA. And in this phase, as we heard from Rob Freiberg this morning, we've had the socioeconomic side of the equation addressed as well. So these have been tools that I think, building on these biological pieces of research, have enabled us to, in different ways, get at risk assessment, risk modeling, and risk prediction for our partners who have used these data in different ways in their jurisdictions to help address some of the challenges that are posed by mountain pine beetle either arriving there or potentially arriving there one day, whether that's through natural spread or potentially through human-assisted spread, say through movement of firewood, which, of course, we all know we don't do that. So I'm really pleased to present 4 speakers today. Our first talk will be by Dezeen Huber, who comes to us from the University of Northern BC. Dezeen has been the theme lead on the molecular analysis component. It's going to be followed by David Coltman from the University of Alberta. I'm particularly pleased that Dave could be here today because he's also my associate dean, and so he's a pretty busy guy. We're all busy, but he's like really busy. Followed by Alan, who's our theme lead for ecosystem dynamics. And lastly, Lael Pratt, who's coming to us from the University of BC in Okanagan, who's going to be speaking to us about socioeconomic resilience. And so these themes arise of factors that are affecting mountain pine beetle populations and the risk of spread. How do we use that information to develop better models? And then relating this biology to ecosystem services and the communities that are impacted by these.